We're going to move on to pre-calculus. You use division in pre-calculus. So I wanted to show you this box method of division. This is called the dividend. It's the bigger term that's being divided, and you're dividing by the divisor. So the way you set up division using the box method is you make a box that has the height of your divisor. So this is like x plus 2. And then I might need another box. I forget how many boxes I'm going to need, but I can always add a box on the end if I need another box. So I'm taking this big term and dividing by x plus 2. My quotient is going to end up here. So this is going to be my quotient at the end. The dividend is going to end up inside the box, because the quotient times the divisor should give you back the dividend. Just like multiplication, you multiply two factors together, you get what you started with, kind of thing. So your first step is to put your dividend in standard form. So you want your dividend in standard form. It is. So 2x cubed is the first term that you're going to write in the top left of your box. Your dividend has to all end up inside these boxes. So 2x cubed goes first. So now you fill in this top term of your quotient. So what would go up here so that this number times x gives you 2x cubed? It would be 2x squared, because 2x squared times x is 2x cubed. Are you with me on that first step? You might feel a little bit lost the first time through. That's okay. We're going to do it a few more times. So your next step is to take your 2x squared times 2 to get this next box. So what would go in that bottom box? 4x squared, right? So we want our dividend to end up in here. How many x squareds are in our dividend? 5x squared. We currently only have 4x squared. So how many more x squareds do we need? One of them. So you're going to put 1x squared so that these two boxes together add up to the 5x squared that's in your dividend. Now you're going to go through those other steps that we've already done. What would go up here so that this times x is x squared? X, right? So x times x is x squared. What about x times 2? 2x. So now 2x, what needs to be my dividend? Negative 3x. So what am I going to put in the next diagonal box so that when I combine these two boxes, they add up to negative 3x? What has to go up here? Negative 5x, because negative 5x plus 2x adds up to the negative 3x that I want. So now I fill in this part of the quotient. So this is going to be negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. Is negative 10 what I wanted? No. If it had been negative 10, then they would have been factors of each other. I'm going to have a remainder in this case. So if negative 10 needs to get added to one last number, what do I need to put out here? So I need to get positive 4 in the end. So positive 14 is actually going to be the remainder of this problem. So the quotient is 2x squared plus x minus 5. So it's 2x squared plus x minus 5 with a remainder of 14 is your final answer. And just another FYI, another way that you could write your answer is 2x squared plus x minus 5. Instead of writing an r, you can write your remainder divided by your divisor. So 14 over x plus 2 is the same as writing remainder of 14. So you can choose how to write your answer. That's acceptable for me because we're just barely learning division for the first time. But like on, I don't know, on something else, you may see it written like this. You put the remainder over the divisor. And it's the same thing when you do division, right? So if you had 25 and you're dividing it by 6, how many times does 6 go into 25? 4, and 1/6 as a remainder. So you're putting the remainder over your divisor. Okay, so let's try another one. So I'm taking this big thing and dividing by x minus 1. So the x minus 1 goes on the outside of the box. I don't know how many boxes I'm going to need. I make sure that my dividend is already in standard form so it doesn't mess me up. So it's in standard form, so I can put 2x to the 4th in the first box. So follow along maybe on this one more time, and then I'll let you try example 3 on your own. So I want to put 2x cubed up top because 2x cubed times x is 2x to the 4th. So then I follow that through. 2x cubed times -1 is -2x cubed. So now I'm going to look at the diagonal boxes. I want to get positive 3x cubed as my dividend. So if I need 3 of them, and I currently have -2 of them, I need positive 5 of them, right? 5x cubed. So 5 and -2 will add up to the positive 3 that I need. So now I can see you alternate inside of the box, outside of the box, inside of the box, outside of the box. So this is going to be 5x squared now. So this is my quotient, 2x cubed plus 5x squared. So I multiply through, I'd get -5x squared on the bottom. Now I check my diagonal boxes again. I want them to add up to -2x squared up here. So I probably need another what? Positive 3? 3x squared, so that these two together add up to -2x squared. Now I do the outside of the box. What times x is 3x squared? Plus 3x. So 3x times -1 is -3x. I got to go another box, right? So let's see, I need how many? Oh, this is a good tricky one. How many x's are in the dividend? 0x, right? See how it skips that term? It goes right from x squared to the constant of 8. If it has to add up to 0x, you need to add 3x then, right? Because -3 and positive 3 will add up to 0. So my last term would be plus 3 up here. 3 times x is 3x. 3 times -1 is -3. If this -3 had just matched what I had in my dividend, there would be no remainder. But -3, I need to get to positive 8. So I'd have to have what? A remainder of 11. So my quotient is this whole thing. 2x cubed plus 5x squared plus 3x plus 3 with a remainder of 11. So division is a lot of work. You'll learn in pre-calculus there's another method called synthetic division, which is a good shortcut to use sometimes, but it doesn't apply to every situation. So that's why I'm not showing you that method, because I want you to have division that you could use for any polynomial division. Okay, so before we go for our walk, maybe I can do the last couple divisions at the end. We'll just keep going if you... I'd like you to try 3, and then I think we need a little break. So you're using division on examples 3, 4, and 5. The first one, they just want to know, is it a factor? And if it is a factor, find what 0, meaning what x-intercept. So like the first one would have an x-intercept at -3 if it works, right? If this divides in, then we know that there's an x-intercept at -3. So you have to see if you get no remainder, then you know that it is a factor. So see if you can do example 3 on your own. Yes or no, is it a factor? Yeah, sure. Did you what? Oh, right there. Oops. I didn't. I thought this was a bigger problem, so I gave myself more. You can just add another box. Another box. More. Yes. It depends, because we were dividing by linear function and three boxes, we could divide by the quadratic function, you actually really less. You have to do it divided by quadratic. Quicker, basically. I would just do, for this one, yeah, we start with three. And then you need, this just depends on there's two terms. Three goes down the side. How are you guys doing on division? Good? Yes. Yeah, and then they're asking you what would be the corresponding zero, so I just said x plus 3 plus an x plus 3. Yes, because you got no remainder, right? Yep, and then they wanted you to find the corresponding zero, so they just wanted you to say that x could equal negative 3. It does. You're actually going to put one here and make a third box. Why don't you do 3 and 4, and then if we need to do 5 together when we come back in, we can. Just because 5 has 3 terms in the divisor, so you might need help with that one, I'm not sure. But 3 and 4 are kind of the same. All right, I'm going to use the restroom quick, and then we'll go out. See if you can at least do 3 and 4. If you want to start number 5, I can do it when we come back in if you need help, but it's just different because you're going to have 3 boxes now down the side. So you just need to allow for that additional number down the side of the box on number 5. So I'm going to use the restroom, and then we'll move on. Did you get yes, no? Did you do 4 or 3 and 4 and got yes, no? Or need help on 3 and 4? You guys look like you're in a working mood. You want to go out for a walk, though? Don't want to go out? Do you want to go out? Yes, most of you do. Okay, you can stay in, Ginger. You going to work on the review, maybe? Or whatever. You good to go out, the rest of you, though? Jossie? You're not sleeping. Right. So, no Willem, no Finn, no Chenoa, no Ginger. Next. Kraken.
Okay. So
Which one are we looking at?
I had trouble with these.
Oh, composition. Yep.
Yeah, because there's no like actual.
So
I was just
G of T, they basically want you to plug negative T into negative T. You'd have negative T, which would be T. Is that the right answer? Hopefully. 12. T.
yes. Okay.
So you're
So
like
then-
plugging the same function into itself twice, basically.
Okay. And then this one though has a different variable.
Which one?
These two.
Yep. So you're going to end up with a variable first. So you're going to do 2 times n over 4 minus 5. And you're going to get a function that has n in it. So you're going to do 2 times n over 4 would be what? N over 2?
Yeah.
So you have n over 2 minus 5 as your first function. Okay. So then you're going to plug that again in here and multiply by 2 and subtract 5 at the end. So it's like getting a function. I think the function must have an n in it over here. 15. Yeah, see? You're going to get n minus 15, hopefully.
And then for 20.
Yep. So same thing. So you're going to plug first x over 3 in for x, so you'll get a function. So you'll have 4 thirds x plus 5. And you're going to plug 4 thirds x plus 5 again, multiply by 4, and then add an additional 5. So it's like you have a function instead of a number. Oh man, Conway Elementary School had a COVID case. Well, hopefully I didn't get a phone call. Well, because that would mean my kid would go home, but. I hope for my kid's class. I don't know. Well, his buddy was out with a stomach bug for the last 2 days, so I hope he didn't get a COVID test and it came back positive or something. There's only like 10 kids in his whole class. You know, so chances are low. Oh, yeah. All right, ready? Do you want to go out the back door again?
Yeah, back door.
pneumonia or something. Hello. We came back. I got back with a donut.
My grandpa also has a black spot on his lung. He has basically cancer, but he doesn't want to treat anything for it. He doesn't want to go deep.
How old is he?
He's 72.
Oh, he's still kind of young.
Yeah, but he's like it.
He wouldn't want to go. Does he think that it's actual? He doesn't know if it's cancer or not.
No, it's just a black spot. But he doesn't want to go through chemo or anything because he doesn't want to do that to my grandmother.
Yeah, yeah.
So.
All right, so I have a gratitude thing that I'm going to do, but I think I'm going to do it tomorrow because I'm going to have you trace your hand and I'm going to make a door decoration out of all our hands. But I think we have more time tomorrow after your test because I don't think your test will be that long. I'm not making it super long. So let's just for today write something that we're grateful for just in our gratitude journal. And I'm going to do that too because I did the hand activity this morning, so we're just going to switch that to tomorrow for this class, just because that's going to take up the last part of our time. So I'd rather just write down something that we're grateful for. Today is Thursday the 10th. We're writing down something we're grateful for in our gratitude journal. And then we'll go back to the, I think maybe what we should do is pause on the division sheet because I'm not going to put division except maybe as a bonus tomorrow. We have some people absent today. We just started it today. But I'd like you to hold on to that division sheet because I think that we're going to do, some more division practice when we go into virtual. I'll make that like an assignment one of the days in addition to like doing some exponent work. So if you could take out 340 because you've got 3 pages to do, you could probably do the first page right now. And then that way you're skipping the back of page 1. So you're just basically doing, there's actually 3 division problems on here as well. So you're doing page 1. And actually, if you want to skip the 3 division problems, if you don't care about the bonus, you could skip the 3 division problems. So just do problems 1 and 2 on the front page of 340, and then completely skip this page, right, with all the graphs. I might have you do that as an assignment in virtual, but I could walk you through the strategy. The last page of 340, actually, why don't we just say you only have to do the last page of 340, because basically that has something of everything on it. So skip the one that has the crazy graphs on the back, unless you already started it. Then if you want to trade half of that for the one you have to do tonight. But if you could just do the very last page of 340, the first function on it is x minus 2x squared. So the only page you have to do is the 340 front and back that has number 1 as y equals x minus 2x squared. You're doing number 1 through 16. Right? So that's that. Does everyone see the one page that you have to do? Because you've got 15 minutes now to get a good chunk of it done, but it has operations, questions about degree. It does have some division. It does have some factoring review. End behavior is telling me if the right end is going to go up or down, and the left end is going to go up or down. So everyone's clear on what they need to finish for classwork homework for tomorrow, right? Just the very last page of your packet. It's only 340 front and back, that's 1 through 16. The other page we're not going to do for tomorrow. I may assign it for like during virtual. Okay? And then you don't have to finish the rest of the division page because I want you to move on to the review. And I'll make an answer key so that we can check it before our test tomorrow. And if there's questions you want to do together, we could. So that would be like Is it cubic, quadratic, linear, and then number of terms, trinomial, binomial? That is equal to the degree of the function. So quadratic, the maximum it could have is 2. Oh, shoot. I forgot to hit stop.